work. Okay. So welcome back, everybody. I hope you had a nice lunch break, that you make some refreshment during this break. Okay, we will continue. I don't know if you need the lights or we can stay like this. I think it's better even. It's okay, good. So we will continue this afternoon with 2 more sessions for those of you who will stay till the end. The first one will be about data scope in Inspire. So I will go a little bit into the more details into the data specification, or we are calling it's the name for the technical guidelines for data specs. Also I will show you some concrete examples. And the final session after coffee break, we will go to Inspire GeoPortal. We will try to do some exercises. I see some of you have notebooks with you, so you can also follow these exercises. That would be nice. Okay, before we start with the presentation about data scope, I promised you to go to make this navigation through Inspire website. I think this is very important, and I will try just to show you the content. So this is the main Inspire web page, and actually all the information about the Inspire, everything what I was actually talking today, more or less you can find on the Inspire website. There are a lot of links also here, but let's start with the main content. So on the main page, on the main page, first of all, you can find legislative documents, starting with the Inspire directive, everything about the legislation. So all the Commission regulations, all implementing rules that we were mentioning today. Also on the main pages you can find some news, what is going on, for example about the conference here in Denmark, and so on and so on. So there are a lot of information here. But what is important maybe for you as a users or people who are actually implementing Inspire is to take a look on the left side, because you have several sections starting about this more general section where you can find some information about the Inspire in general. Again, legislation, history. It is nice to see who is who in Inspire with clear explanation what are the roles actually of different bodies in the Inspire. So starting with DG Environment, GRC, if we go a little bit down, what Eurostat and European Environment Agency, Inspire Committee, who are the members, member state contact points, so which are the national contact points, who is involved. You can find the list of the contact. I will not go through. Then also here is a nice link to Inspire Library. So Inspire Library is, let's say, I would say, a very big repository of different documents concerning Inspire. There are a lot of white papers from the beginning of the Inspire, before the directive came into the force. You can search, you can find reference materials, you can find here the projects which are connected with Inspire. You can find state of play reports here. So these state of play reports were reports actually came actually before the monitoring and reporting. So there were a lot of reports before, starting immediately with the Inspire directive. Yes, and you can find also all the Inspire conferences. The next section is about the implementation. So you can see the roadmap. Actually, this is the picture that I already show you through the presentation. Monitoring and reporting. First about legislation, and then you can find the data for particular member states, for particular country. So if you click on the country, you can find a report. You can get the reports, indicators for each year. We said it is available starting from 2010, and the last information we have for 2013. But as far as I know, very soon will be here also indicators for 2014. Usually it is in May, so I think all the member states already sent indicators for 2014. And new reports will be available in 2016. Then we have IOC, Initial Operating Capability Task Force. About them, actually, we said that now it is under this maintenance and implementation framework. Link to Inspire Geoportal, and this new maintenance and implementation framework about MIG. Here you can find, as I said, this call for the pool of the experts, which is open-ended call, so you can still actually apply to this call if you are interested. You can find, you can see actually who are the experts in your own country. So there is a possibility to see to check the list of registered experts, and then you can also search through country and so on, which is sometimes good if you are searching for someone particular in your country, or you want to get in touch with someone who is expert in some field of Inspire to get in contact with him or her. What more? Okay, and then there is a section adoption. I will not go here through. In adoption, again, we have roadmap, so you can follow how it is supposed to go on. Implementing rules, monitoring and reporting, metadata, data specification, and so on. Spatial data services and data service sharing. There is a section about stakeholder participation. You can see some statistic data about spatial data interest community, but also you can find information about legally mandated organizations, drafting teams, and thematic working groups. A list of registered organizations. You can see the list of organizations that are registered. Consultations and the results of consultation processes. You can express your own interest, and there is a news and events section. However, here you can find several links. The Inspire Geoportal is already available up, but here there is a link to Inspire Forum, which I mentioned. And Inspire Forum is also a very nice source of different information regarding Inspire. There are a lot of actually thematic groups working on different issues of Inspire, so I kindly can recommend you, if you are interested, you can register and you can open your own group. You can discuss different topics about Inspire implementation. There is also one group regarding Inspire trainings, so you can find this presentation from today also there on the Inspire forum. So I think it is really good source to exchange knowledge, best practices, and so on. So I kindly recommend you to join the Inspire forum. And also I mentioned here Inspire registry. We will go a little bit later in some details about Inspire registry, because Inspire registry is something which is very important. There are currently 4 registers available. Yeah, these 4 here. Just a second, where did I lose my mouse? Okay, it's automatically recognized the time here, but let's put where is English? Okay, it's here. Yeah, okay. We have inside Inspire application schema register. So for all the application schemas coming from data specifications, Inspire code list register, very important, Inspire feature concept dictionary, and Inspire theme register. So in the moment we have 4 registers there. This Inspire registry is also maintained in the GRC as a technical coordinator. They are maintaining also the Inspire registry. And then yeah, okay, maybe I should go back to Inspire website. For you, probably we will speak about data specifications. You can go also here through the Inspire registry, but data models for all the data teams are available in the different formats, so you can use it as a feature catalog, HTML view. You can also find some mapping tables, or for the enterprise architect and SVN. So there are possibility to take and download in different different data models, and here you can find the explanation of each different type. I think probably for you who are implementing these GML application schemas are the best solution. But if you are developing something, you can also use this for enterprise architect, maybe if you are using this software in developing UML models, or if you want to extend some data model, and so on and so on. Okay. There are a lot of other informations here available, so it's up to you when you have time, but probably all of you already visited this site. But so the idea was only to show you where are the information, where you can find information that you need for your implementation. Okay. Any question about this Inspire website? Or if you are still missing something? So more or less everything is available here. Really on this, it's very informative website, so you can use it, and I hope it's user friendly. But a lot of information that you need, you can really find on this website. Okay, I will keep it open, so then we can see later if we still need to go there. As we said, this third session will go a little bit more into detail into the data scope in Inspire. So we will try to demystify actually these data models and try to show you that it is not so difficult. Maybe it seems so, but if you have some really basic skills in UML, you can easily read these data models and recognize what is actually inside. So, okay, so the content of the presentation will be, we will go into the Inspire data teams, we will speak about interoperability, then I will show you some examples of data specification and how you should read data specification. I think this is very, very important. And then we will also take a look at some particular examples here. Okay, where we are using these data models, I show you this picture already today in the morning, in first or second session, I think in the second one. So we said the crucial or the major component of spatial data infrastructure of Inspire is actually spatial data. And for spatial data, if we want to achieve interoperability between different teams, we need to use interoperability target specifications. These elements or these objects, spatial data objects, are clearly defined in the implementing rules, but also in the data specification. But we said what was the difference. So in the implementing rules you have something what is legally binding, and then you have this target specification, technical guidance, or we are calling them also data specification, in which you have more detailed explanation of what do you need to provide. Okay, so to be able to combine data to achieve this interoperability, we need to harmonize data with this interoperability target specification. Here we have these 34 teams, so for each of the teams we developed actually separate technical guidance or data specifications. All of them are available on the Inspire website. Also there are some versions of these documents, different versions, and you can clearly see, let's say, improvement from one version to another. To the last version is a 3.0, which was published for a final version of the implementing rules together with the implementing rules. Okay, we already mentioned those data teams, so I will not repeat this. I mentioned this morning actually the background for these 34 teams. Why do we have just these 34 teams, or should it be less, or should it be even more? And we mentioned that there were some working groups established back in 2002, and they were exploring actually existing legislation in that times. They were exploring existing directives. They were trying to see what are the needs of the users regarding the different directives. There are two nice documents actually available in the Inspire library, which I showed you. The one is Inspire Working Group on Reference Data and Metadata, Reference Data and Metadata Position paper. And this paper actually provides actually it gives, I would say, explanation for the reference data, why they choose these 9 teams in the Annex 1, what was the reason, and what is the purpose of these teams in Annex 1. And the second paper, it was produced by this Inspire Environmental Thematic Coordination Group, also in 2002, and they were dealing with environmental thematic user needs. Also, it was a position paper in which they tried to see and to explain for the Annex 2 and Annex 3 data teams, which are more thematic, let's say, what was the reason why they choose these data teams in Inspire. So these documents actually give us the background of these 34 data teams. So whenever you think why exactly those data teams, not some other, you can find really nicely written explanation actually here in these two documents. Okay, so it's everything about interoperability. So through the data specification, we want to achieve interoperability between different teams, so cross-thematic interoperability, but also between different domains, which mean cross-domain interoperability. And the starting point actually here is that before Inspire, before development of spatial data infrastructure for user was very difficult actually to combine, to interpret heterogeneous data which were in different formats, to identify them, to extract and post-process the data that they need. So it was obviously lack of interoperability. And Inspire actually is aiming to provide access to spatial data via network services and according to harmonized data specification to achieve this interoperability of data. However, some of the principles which we have here is, first of all, that data sets used in member state may stay as they are. So this is very important to stress here out, because usually there are some misunderstandings, and the people from member states, data providers, they think, oh my God, we need to change our data models, how it is very complicated, what does it mean, and so on and so on. No, the answer is no. So you don't have to change your data models, so your data can stay in your model which you are using. But what you have to do, you must just harmonize. You have to provide one more, let's say, layer or one more service out of your existing models, which is actually harmonized with the Inspire data specification. And actually you can do it in, let's say, two ways. Either you will make some kind of offline copy of your data in one moment and provide such a data, or you can use some online services to provide this data, so to transform them, let's say, on the request into the Inspire data models. It is more about the transformation, and we will not talk about the transformation today. However, there are a lot of other workshops, either today but also yesterday were some workshops. There are also some presentation on the conference dealing with the topic of transformation. So if you are interested just in the transformation topic, maybe you should visit those presentations. We will not go here into the details. And data or service providers, as I said, they have to provide a transformation between their internal data model and the harmonized data specification. This is actually for member states, which is an obligation. So to provide this transformation between those two models, let's say. So just remember there's models that are using in the moment, so you don't need to change your data models. They can still be as they are. Then I show you this picture already this morning, and this is very important picture again to stress the difference between these two types of documents. So on the one hand we have legally binding documents, legislation starting with the directive and different in implementing rules or commission regulations, and this is what is legally binding, and this is what actually member states must implement. And then we have this technical guidance or data specification. We are calling them data specification, in which actually we are trying to say how member states might implement it. So it's some kind of implementation specification. However, we said also this morning that member states or data providers, if they don't want to follow these guidelines, they can go in their own way. So they can choose maybe some other guidelines or some easier way if they think it exists, something like that. But in that case, they must provide what is written here. If they choose to use technical guidance, which is a recommendation, of course, then it will be probably easier for them to implement Inspire. Okay. The question is, why common data specification? Why do we need a common data specification? I think it's very logical. Because member states should make available data within the scope of Inspire using, first of all, the same spatial object types and definitions. This is important because usually in different countries, the spatial objects we can speak or we can have same, let's say, title or whatever, but the meaning can be very different. So this is very important that we all using the same spatial object types together with the definitions of those spatial object types. It's important that we are using the same attributes also together with definitions, types and code list, and also relationships to other types. For example, building height, building size. So in different countries there are different standards. What does it mean actually building height? From which point to which point we are measuring this building height, and so on and so on. So again, if we don't have the common specification how to express this building height or building size, probably that we will have different data between different member states. And in that case, we cannot really use those data for our particular use case or for our particular project. Common encoding. For example, GML application schema, which is actually just a recommendation, and also common portrayal rules. So when you are using services like WMS, that you know on each layer which data actually you could expect on the particular layer. This is very important. Yes. Exactly. Actually, yeah, I agree with you. This is true, but at least we have layers specified in the implementing rules. So we know at least we have layers. No, this is true. This is true. I completely agree with you. But I think it was very hard or difficult really to go into such a details to put these portrayal rules into the legally binding document. I think that was probably that was the reason why it was chosen, to keep it in a technical guidance, but at least to define, common layers which you are obliged to provide without these portrayal rules.
countries, and every module provide different cartography. So I will see
yeah, I completely agree with you. This is the issue which probably needs to be solved somehow, because otherwise it will be a little bit difficult really to combine. I completely agree with you. This is true. But in the moment, these portrayal rules are, as you said, only in the technical guidelines. So, but we can presume that majority of the providers will use technical guidance, so that we will have really possible to combine and to use this. Okay, so these all common rules, let's say, serving us actually to facilitate interoperability at the pan-European cross-border applications, for example, in information systems, reporting system, forecasting models, and so on and so on. And as I said, for each data specification, the model is expressed through UML, Unified Modeling Language. So to be able to read it, so you need at least some basic knowledge skill about the UML. Okay, a little bit about the development of this data specification. I think this is important to see how actually all of those data specifications were developed. Actually, the start was by developing of conceptual framework and specification methodology. So there are several documents, you can find it here. DSD 2.3 up to 2.7. There are also some other documents, and these documents were really some kind of basis in the development of those data specifications. So, for example, this definition of annex themes and scope, generic conceptual model, methodology for specification development, and guidelines for the encoding. And actually all thematic working groups were using this basic documents in the development of each data model for specific or for particular data theme. This is important. All of these documents also you can find in Inspire library, so they are all publicly available. There are also one nice report from 2013, I think, about the development of data models. It's available on the GRC website. If you want to know something more about really development of those data models and data specifications. As I said, thematic working groups were using this document, and they were working really based on conceptual framework, common specification development methodology, and according, of course, to Inspire roadmap. And this thematic working group, they were preparing implementing rules based on the data specifications. So you will see the development of these two types of documents. So from on the one hand, implementing rules and technical guidelines or data specification were parallel process. So these two types of documents were implemented actually parallelly. And I mentioned already this morning that in all data specification, all technical guidelines, and also in implementing rules, a lot of standards were used. First of all, the series of ISO standard, ISO 19 and 100. XX, let's say, a lot of OGC standards, domain standards from different domains, and also according to those standards, this generic conceptual model was developed to help further implementation. Based on that, actually, we built data specification for specific data themes, and of course they are used for different reporting, for different new extensions, and for different new applications. So this is actually what is Inspire when we are talking about in terms of standards, and we can really say today that practically this standard or these data specifications and other technical guidelines are really some kind of de facto standards now, recognized worldwide, not only in Europe, but in the also other parts of the world. Regarding stakeholders, or who worked on the development of data specification. As I mentioned already, different technical working groups. For example, for the Annex 2 and Annex 3 teams, we had 19 working groups. In each group, we have several people, TVG facilitators, editors, but also domain experts, which is important to say because usually people are asking, oh, okay, there is a team geology, who worked on it, who proposed those data objects should be in the geology. They were really domain experts, so it didn't. There were not only people with a profession in geoinformatics or something like that, but there were also people who are really working in the domain. So for each of data team, we had really domain experts in these technical working groups. However, there was also EC Inspire team. Technical coordination was done by GRC Inspire team. There was a data specification drafting team, and also a lot of stakeholders were engaged. I mentioned you this morning that we had this consultation and testing phases, that we received thousands and thousands of comments from different member states, from different stakeholders, data producers, users, and so on and so on. And also I think it's important to mention that there's in the moment, and there were before, a lot of projects already using Inspire data or producing Inspire data according to Inspire data specifications. One more thing which is also important to mention is this, let's say, level of interoperability. So it was not really easy to find the appropriate level of interoperability. You can imagine that for some data team, you can provide a lot of many objects. But if you go really very wide, then probably it would be problem how to manage all these objects, how to define them, and so on and so on. So that's why we try to really find some appropriate level of interoperability, starting really with some reference data set, and for those data which we can concern maybe more as some kind of business data, but probably is not the right word, like more thematic, more detailed data, we somehow avoid it, but we leave the opportunity for data providers to easily extend data models. So in the data specification and what is written in implementing rules, you will find really the core model, core application schemas, core special objects that you are obliged to provide. But then, if you have more data, if you want to provide much more data than Inspire actually asks for, then you can easily extend your data models, existing data models from Inspire, and extend it with new objects, with new attributes, new elements, and so on and so on. Okay, I mentioned this conceptual framework. I will not go into the details. You can find much more information on Inspire website, but the idea was really to provide repeatable data specification development methodology and general provisions for the data specification process, which is valid for all spatial data teams. And this generic conceptual model is using a set of interoperability elements. We can divide them in 3 categories, like fundamentals, data modeling, and data management. So all of these elements were concerned in the development of conceptual framework, and then using also best practices and generic conceptual model and specification development methodology, we actually developed those data models for different data teams. So on the one hand, as I said, it was a parallel process. We have technical guidance, and on the other, we have implementing rules. Implementing rules are something which is legally binding. Technical guidance not. We already explained it. And this was some kind of, let's say, development cycle, how this implementing rule and data specification were actually developed. Starting by drafting of technical part of implementing rules. A lot of stakeholders were engaged using different reference materials, experts, projects, and so on. Version 2 of data specification were on testing and stakeholder consultation. After the testing and stakeholder, it went to drafting of version 3. It went then through commission inter-service consultation, and we produced draft technical guidance. After that, it went to regulatory process, so publishing of implementing rule as a regulation or decision, and guidelines, final guidelines of data specification. And of course, what I mentioned already before, through the maintenance and implementation, probably there will be some corrigendums, some things that will need to be changed in the future. Also, a lot of use cases were used for the development of data specification. So it started with as-is analysis, identification of user requirements and special object types, gap analysis, data specification development, implementation, testing and validation, and of course nowadays maintenance. Also, during the development, cost-benefit consideration were also taken into account. It was also very important to achieve cross-thematic data interoperability. So not only interoperability data teams, interoperable data teams, but also to achieve cross-team data interoperability, and on the other hand also to serve purposes of different directives for the reporting issues. So that's if you look at data teams, you will find a lot of common elements that are shared actually, and that's why this generic conceptual model was introduced in the development of the data specifications. Okay, there are several, or let's say, key pillars of data interoperability, which are really important, and these are here the conceptual data models with object types, properties, relationships, cross-domain harmonization based on common modeling framework and managed in common UML repository, encoding, so conceptual models independent of concrete encoding. So you will, if you read or if you read already technical guidelines, you will find that, for example, GML is only recommended encoding. Harmonize vocabularies to overcome interoperability issues caused by free text and or multilingual content, allow additional terms from local vocabularies and registers, which I already mentioned, to provide actually unique and persistent identifiers for reference to resources, but also to allow their consistent management and versioning. All of these pillars actually are fully described in the documentation, which is available through the Inspire web page. Okay, and now we came actually to data specification. So first of all, I would like to show you how you should read these data specifications. And when you open data specification, we can open later directly one on the Inspire website. You will see that some parts of the data, when you go to the content, are actually usually shadowed in gray, and which means that these parts of data specification are common for all data specifications. So once when you read them, you will know that these parts are actually common for all data specification for all 34 data teams. But usually what is specific for each data team is this team-specific executive summary, overview, data content and structure, application schema or application schemas, if there are several application schemas, which includes UML diagrams and feature catalogs, data quality and minimum data quality requirements and recommendations, and regarding metadata, this recommended team-specific metadata elements, data capture and portrayal, as colleagues said. And then there are some annexes in data specification. We can say this Annex A is actually normative annexes. It's an abstract test suite. And we have also some annexes which are more informative, like use cases, Annex C with code list values, and you can have other annexes D, E, F, and so on, with some particular examples. So this is what is important really when you go to particular data scheme, really just to see executive summary, to see overview, which gives an wider description of a theme, and then actually this application schemas, data content and the structure. Of course, then if you are a provider, you should concern also this data quality, minimum data quality requirements, metadata, data capture, and portrayal. And then at the end you have this abstract test suite, which is also very important, especially for the providers of inspired data, because it serves that you can claim if you are really inspired conformant or if you are not. So this is something which is very important, and there are a lot of actually still discussions about this testing. There are a lot of work on it, research, I would say. There are also some sessions in this week on the conference regarding testing, and this is something really important, because some people, they would like really to put some stamp, I'm inspired conformant. Then it's a question, how can I prove that I'm inspired conformant? Other people are asking if it is really necessary, or can we avoid it? I mean, if I am providing my data, I am sure that I'm inspired conformant. I will just say that I'm inspired conformant. Some people are saying, okay, but probably maybe European Commission must be this body to say, yeah, this is inspired. But I think it's not possible, I would say. So maybe on some national levels should be some independent organization, or I don't know who, or national contact point who can really say, okay, you are providing data conformant to inspire or not, but it is still a topic for the discussion. So it is still something which needs to really to be agreed. What is saying here actually about this conformance, you have one metadata element for the conformance, and if you are a provider of data and you think you pass all the tests here in abstract test suite, you will claim, okay, I'm inspired conformant. But then it's up to users to believe you. They can believe you, or maybe they won't, or they could not. It is something which is still, I would say, really under discussions. And then when you read data specification or other technical guidance, you can find different types of requirements and recommendation. So you can find something like this. If it is marked with red, actually it says it is an implementing rule requirement, so which means this is something what is obligatory. So this is something what I really must provide. But then you have other type of requirements. This says it is a data specification requirement. So if you are using technical data specifications, then you should also follow this requirement. You can avoid it, but then at the end you cannot say that you are conformant with the data specification. If you are following only these types of requirements, and this is what is written in the implementing rule, so in the legal text, then you must then you can actually state that I am inspired conformant, but only with the implementing rule. So I fulfill everything what is mandatory, what is obligatory in the legal document. Then in technical guidance you can find also some recommendations which can help you in the implementation, and as well maybe some still open issues which are still open for some future maintenance and implementation. Okay, a little bit statistics for coming from data specifications. In the Annex 1, actually, more or less for each data team, we have only one core application schema. In hydrography, we have some more, and in the transport networks. And there are some extended application schemas already proposed, for example, in the protected sites. In the Annex 2, we have for elevation 4 application schemas, Geology 3+1 plus GeoCML. Here we have orthoimagery 1 application schema, and in land cover actually we have 3 core application schema and 1 extended. In Annex 3 there are some more application schema. Usually is only 1, but in some cases, like for example land use, you have 5 application schemas. In buildings you have 3 application schemas plus CTGML. In utility and governmental services you have more application schemas and so on. Overall, there are 67 core application schemas and 29 extended application schemas. Plus, there are a lot of actually use cases which you can find in data specifications, and which can be very helpful for you to understand how and for what is the purpose, how this data team can serve. So there are 138 use cases overall in data specifications. And now we are coming really into the point. So this is the question is actually for you. What is this? Can you read this? I mean, who is familiar with UML? 1, 2, 3, 4, 5. Good. Others? Is it you are not dealing? So probably I presume that when you see something like this, is a bit complicated to read what is actually content of this. I have very short presentation about UML basics, which I would like to share with you, if you agree. I hope it will be useful for all the rest. Maybe just to understand some basic principles, and then probably it will be much more easier for you to follow. Okay. Okay, so we will come back to this diagram later. But actually, okay, UML, what is UML? First of all, it's a unified modeling language. It is a graphical language, actually, because you are expressed everything with the graphics and with diagrams. And there are, in general, 2 types of diagrams: structure diagram and behavior diagram. And usually in the data specification, we are using only these class diagrams or sometimes object diagrams, so more or less structure diagrams. But sometimes maybe in the explanation of some use cases you can find also some use case diagrams when you are reading data specifications. So it's a very wide, I would say, language. It came actually from object oriented programming. So that was the basis, but nowadays this UML is really used overall for different purposes, especially in the modeling. And the good thing is that once when you use some diagram, it should be readable for everyone who knows UML, either here in Europe, in Japan, Australia, wherever. So you can share your UML diagram, and the people, if you know the rules, I mean, of this language, then you can easily follow, you can understand what is actually written there. So maybe first some definitions. So we are starting with classes. It's also coming from object-oriented programming, a way of thinking. What is the class? So the definition says it's a description of a set of objects that share same attributes, operations, relationships, and semantics. Objects are also called instances of the class. So we can imagine that this is a one class, and we have inside different objects, but they are all sharing same attributes, operations, relationships, and semantics. How we draw these objects and classes in UML? Actually, we are using such a rectangle. Usually at the top we have a class name, and the convention for writing is upper camel case. Then we have some attributes. Actually, in this case we have attribute seat number and the color. We can define either these attributes are visible or not. We can define also the attribute type, for example for the seat number that it is an integer, for the color that it is a color. Also we can define the multiplicity. So in this case we are saying that color at least must be one defined, but it can be more. And then for the attribute name, the convention is lower camel case, and then we can also put some other things we will see later. But this is the very simple overview of a class, for example car in this case, which says a car is characterized by a seat number and one or several colors in this case. What is important and what is the power of UML are the different types of associations. In this case we have this generalization or inheritage, which says that definition that it is a taxonomic relationship between a more general element and a more specific element, and we are using this closed arrow to represent this generalization. In this case it says that class B instance is also class A instance, or it can be said like this, that class B instances share the same characteristics as class A instances, or that class B specializes class A, or that class A is more abstract or generalized than class B. So it will be much more easier to follow this here. So we have this abstract class here as a vehicle, and with the two attributes, so with the owner name and the construction date. And then we have classes as instances of this upper class vehicle. We have car, we have boat, and we have a bus. So from this diagram we can read that all these classes, car and boat and bus, these classes are also vehicles, and also that all of these classes they are sharing the same attributes as the upper class vehicle. So which means that car also has owner name and construction date, boat also has owner name and construction date, but boat also has a draft. And also again for the bus, for example, bus also has owner name, construction date, but also as an additional attribute it has a passenger number as an integer. So this is very nice when you are drawing such different classes, to see immediately what is the association and how they actually inherit some elements from upper or abstract class. Then we have a normal association, which is a relationship between classes that specifies connections between their instances. So we have class A, class B. Usually we are putting here association name. We can put also the role for the class A and role for the class B, and we can put also multiplicity. So we have here a company which is the employer, so the role is employer. We have a person, class person, which is employee, and we can see that company can have 0 to many persons employed, and again persons can be employed by one or more companies. Same example maybe here. Then we can have such a type of relation. Usually you will find it in data specification in many data models. For example, here we have a kinship relation between individuals, and this relationship says that all individuals have exactly 2 parents, and each individual can have no one or several children. Okay. Aggregation is also something which is very useful. Aggregation is a relationship between instances of a class and several instances of another class. So in this case we have class A, which is instance is an aggregate of instances of class B. For example, if you have country and regions, a country is an aggregation, so country can have more regions, and each region belongs to one country. So this is a very simple aggregation relationship. And the composition is a bit more stronger, actually, aggregation. It says it's an instance of a class and several instances of another class. They cannot exist independently, which means we have, again, class A instance is a composite of instance of class B, and you can imagine that, for example, for the composition relation between book and page. So each book has two or many or more pages, but each page belongs to one book. But if we destroy pages here, then we will destroy also the book. So it's a more stronger relationship between, if we are using this composition. Then you can also define navigability in UML, which indicates whether instances of one class can see or know about instances of another class to which they are related through an association. Usually you are using this open arrow. And in this case, person instance knows the company instances it is associated with, but the company instance doesn't know the person instances it is associated with. Nice thing is is these notes. Notes you can use to put some comments in natural language, or you can use it to express a constraint. So in this case, we can just put some comment on class A, or we can use it as a constraint. Usually constraint, you can put it directly into this rectangle of the class, or you can use it as a note that, for example, class A object should be like this, or this constraint you can put it here together with the class. And which is also very specific for data specification, we used a lot of stereotypes. Stereotypes actually extend the semantics but not the structure of pre-existing UML elements, which mean classes, attributes, operation, associations, roles, and packages. And usually you have these brackets. You will recognize this by stereotype name and class name, that it's a stereotype. Okay, so what is represented here? Maybe some of you who is not really familiar with UML can try to answer, if you were following very carefully what I was explaining. So this UML class diagram is coming from administrative units. So can we recognize some classes here? Come on, I want to wake up you. I know that lunch was very good, but okay, so first of all we have administrative unit, then administrative boundary. Is this a stereotype? Who knows the answer? Maybe I should introduce some rewards for the people after the whole day training. Yes or no? Yes, because we saw this nice, we can see these nice brackets here. So we have feature type. In both cases we have actually two feature types, this administrative boundary and also administrative unit. And then we have some attributes here. All the attributes with this plus are visible. For example, country for the administrative unit, which is represented, the type is country codes. We have geometry, inspire ID as an identifier. We have name, geographical name. Then we have national codes as a character string, national level with administrative hierarchy level. And then we have some actually attributes which are voidable. Who knows what does it mean? who implemented one of data specification? At least who read it? Probably you, I can presume. Yeah, we can say so, but yeah, it's a bit tricky. Okay, so we can say that very simply that if you don't have these attributes, actually they are not mandatory, so you don't need to provide them. However, if you have it, you need to provide them. So maybe this would be the simple explanation. And then we can see some constraint for this class. Okay, then we have this feature type administrative boundary. We have association in which we have two roles. So administrative unit, the role is of course administrative unit, and for boundary it's a boundary. Again, here we have country codes, geometry, inspire ID, and national level. For the national level, we should use this code list with administrative level hierarchy. And here, if we are using this residence of authority, I forgot to mention, you should use this data type residence of authority with geographical name and geometry with GM point, which is actually voidable. Then we also have this, what was on example, like a kin relationship. We have it here, like co-administer and administer by, and upper level and lower level unit. Of course, that's if we are talking about administrative units, you can imagine that you have different levels of administration in one country, so you can have different levels of administrative units. So, is it clear? I hope at least it's show you how to read this, so, which means if you are really doing on the implementation, if you are a data provider or I don't know on which position you are working particularly, but with some basic knowledge, let's say, of the UML, I think it is not so difficult really to read these UML diagrams. However, everything what is shown here on this diagram, everything is written in the implementing rule, but in another form as a text. And there in the implementing rule you will find, okay, you need to provide this, attributes are this. So this is only the graphical representation which can help you. Of course, you have to know this UML, but I think it can help you really to understand what is the object here, what are the attributes, because it's, I think, usually we are saying the picture is telling more than 1,000 words. So I think it's much more easier to read something from the picture than if you read really the text, because the text is, you know, sometimes is too boring. So yes, please. Okay.
Every one of these attributes are available, but then there is a constraint, at least one of them should be provided.
Okay, good. I didn't work on buildings, so but probably idea. So all of them are, but probably when they were working on this data model, they presumed that at least one of those dates are known. I would say so, and that at least you should provide one of those dates. That's what I'm thinking. I'm not sure. I didn't work on buildings. Actually, colleague who was supposed to join me today, he was working on the building, so probably we can address this question to him. But I can presume that that was the reason. However, all of the other which are not voidable, if you have them, you are obliged to provide them. So this is important to mention. And you can have such examples which colleague just say that sometimes all the attributes are voidable, but then you have some constraints. You also need to read the constraints. It is really important when you are doing really practical implementation. Okay, so maybe I can show you some. I have some examples from some data teams here. Maybe we don't have to go into the details, but maybe started with one which is really easy, maybe cadastral parcels. which is from Annex 1. Okay, so what are the cadastral parcels? So the definition coming from Inspire Directive is that these are the areas defined by cadastral registers or equivalent, and then you can find also some more wider description which says that as much as possible in the Inspire context, cadastral parcels should be forming partition of national territory and should be considered as a single area of Earth's surface under homogeneous real property rights and unique ownership. And it came actually from this United Nations working group. There is a remark also that by unique ownership is meant that ownership is held by one or several owners for the whole parcel, and by homogeneous property rights it's meant that rights of ownerships, leases and mortgages affect the whole parcel. And what is really important is that the Inspire Directive really focuses only on the geographical or geometrical part of cadastral data. So member states, they are not obliged to provide any information about ownerships and mortgages and such things, but of course if they want, it's up to them, so they are free to do so. So the Inspire really focuses only on geometrical part of cadastral data, and in cadastral parcels we have actually four featured types. It's a cadastral parcel, it's cadastral zoning, it's a basic property unit, and cadastral boundary. And I don't know if you can read it, but we have some associations, of course, and here it says voidable, and here it says voidable. So which means that actually member states, they are really obliged to provide is this cadastral parcel, and all the other information actually, if they don't have it, they are not obliged. But of course if they have, they need also to provide this information. But the cadastral parcel, and that's why I think this is really one of the simply data themes in the comparison with the others. Already there are a lot of actually nice examples. I took this one from Czech Geoportal. I think it's from their cadastral mapping agency, and here you can find really already cadastral parcels harmonized with the Inspire, so you can see the services. Here it's a double WMS service, view service for the cadastral parcels, and these three actually layers are also written in the implementing rules. So if you are providing cadastral parcels, you should use layer cadastral parcel, cadastral boundary, and cadastral zoning. So I think it's a nice example. There are a lot of such an example already from some member states, not only from Czech Republic. However, there are a lot of still cadastral parcels provided in national models, so not harmonized with the Inspire. And I think I mentioned this morning that actually from this Czech Geoportal, from their national mapping cadastral agency, you can find also cadastral parcel in their own national model. So they are providing two actually services, one for Inspire cadastral parcels and one for the coming from their national model. As I said, this is what is this theme is really maybe simple one, but there are a lot of other themes which are not so simple, where you have more difficult situation. What I have here, actually we saw already these administrative units, but actually the administrative units were changed. I don't know if you're aware of that, probably yes, some of you who are working on it. So the definition that is that administrative units are units of administration dividing areas where member states have or exercise jurisdictional rights for local, regional, national governance, separated by administrative boundaries. And then there is a bit wider definition that which says that each national territory is divided into administrative units. Administrative units are separated by boundaries, and units and administrative boundaries form a partition of space, which is logical. According to user requirements, it can be distinguished between land and coastal or water parts of administrative units. So this is something new. Actually, we saw already this diagram. And this is something which is actually new for these maritime units because there are countries, for example, Croatia, that have also some units on the sea, administrative units on the sea, and that's why the new model was, so this implementing rule also was, the new model was added also in the implementing rule. So we are distinguished two packages now. One is for the administrative units concerning land, and the other one is for the maritime units. And, again, example from the same Czech geoportal. They are already providing these administrative units with these Inspire View services. So you can find there are several levels starting from first order up to this NUTS 1 and NUTS 3. And these are actually the layers in implementing rules defined for the administrative units. One more example, maybe. Okay, elevation. It's also very comprehensive data specification coming from Annex 2. The definition from the Inspire directive says that digital elevation models for land, ice and ocean surface includes terrestrial elevation, bathymetry and shoreline. And then there is also overview description that the main purpose of a digital elevation model is to provide an elevation property with reference to a specified origin, which is vertical reference or datum, and the property may be height, of course, when the value is measured opposite to the gravity field of the Earth, or it can be depth when the value is measured in the direction of the gravity field. And in line with existing technologies, there are three spatial representation methods provided, and these are grid, vector, and thin, or this triangulated irregular network. So you have packages here. We have these elevation base types, and then we have grid coverage, elevation vector elements, and elevation thin, which can be used to represent the elevation. Yeah, again, I think it came from the same geoportal. Here we have representation as a contour lines. So it's a vector representation, and here are the layers actually defined for the theme elevation. Any questions, or I don't know if I have some more example, but probably don't need it. I just wanted to show you how to read those data specifications and how actually to use it. Oh, let me go back. Okay. So these were the examples. However, if you go into the data specification, and we will try just to go very quickly through one of them, you can choose whatever you want. But as I mentioned already, there are a lot of sources on the internet. You can find, I mentioned you this GRC report, conceptual model for developing interoperability specification in spatial data infrastructure. This report is available on the Inspire website. It was published, I think, last year. And then Inspire data specification, you have an overview here, data models, which I already show you, and also schemas which are available. Maybe we can try really just to go into the one data spec before we finish this session. Okay, so all the data specifications are here. I already show you on the Inspire website. You can see that for Annex 2 and Annex 3 were published in December last year, the final versions. There were also some changes, so that's why we have for the Annex 1 this 3.1. I don't know if you have any particular that we can go through, if you are interested, any wishes. No, so I can choose one, maybe. Okay, let's take maybe C regions, because I was working on it, so I am familiar, more or less. So this was the last version, 3.0. I hope it will work. Yes. Okay, it takes time. Boo. It's about Adobe, probably. Let's try once again. Just a second. Oh, come on. It's not my laptop, so I don't know what is going on, but probably some problem with PDF reader or whatever. Strange. However, when we are still waiting, do you have any questions? Maybe this was a little bit more technical sessions for you, especially for the people who are not familiar really with these technical issues. Yes? What was once again? I did. Then you should provide them. Yeah. Yeah. You can read, there is one small chapter in each data specification about the voidability. Yeah.
For example, cadastre and cadastral growth. Cadastral growth is voidable, but if we have information, we should provide it.
Once again, I don't know what you...
Parcels?
Yes?
Cadastral growth.
You mean cadastral zoning, probably.
Zoning growth. If cadastral zoning growth is voidable, but
If you have it, you have to provide it, yeah? Because cadastral zoning is just municipalities, and usually in countries some cadastral parcel belongs to, let's say, cadastral municipality. It's a usually definition of this. If not, if you are not providing, then you should put clarification why you are not providing it.
We have possibility to not provide.
You have possibility, but if you have it, you should provide it. But sometimes it can be that some attributes, for example, I don't know, sea level or whatever, you don't have it because you don't maintain this information in your data set, or you are not measuring this, or it is unknown. So there are several possibilities when you can declare this voidability, and when you are not providing such information. No? But it is really defined in each, you can find this chapter in each data space. I hope if we can manage to open this, I will show you immediately. but it seems unfortunately that it's stuck somehow. Yeah, we can do this. Let's see. Is it coming? Yes. Okay. Google Chrome is working, it seems. Okay. Okay, I choose this C regions data specification or technical guidelines. So we can go a little bit more into the details. We are still waiting to this to show up. It goes okay. So it is usually my recommendation first, really, when you first have some data specification in your hands, really to actually to read this forward, to see how to read the document, and it explains what I was telling you in the presentation, how it will be much more easier for you to follow. Then you have these gray parts, which are actually more or less they are common for all the data specification. So once when you read them, actually they are common for each data specification. Then you have this executive summary for the specific data team, which is important when you are concerned, when you are dealing with a specific data team. And here you can find really what is specific for this data team which you are implementing or whatever. For example, here for C regions, some acknowledgements, table of content I already show you. Of course, there are some sub-chapters here, but I showed you what you should be focused on. So we have scope, informal description, concept and scope for the C region, that it's a 2D geometry more or less, some pictures. Okay, terms and definitions. Also this picture I was showing you today about the actually this to distinguish what is legally binding and what is not legally binding, what is the content in the technical guidance. Then it is also I also show you this, how you should read these requirements. So there are different types of requirements coming from implementing rules and coming actually from technical guidelines or data specifications, and recommendation. Then we have this data content and structure. This is what is important. Common types, basic notions. Here should be voidable characteristics. This is what you asked me. Okay. Okay, so here is the explanation of the voidability, which says that if you said that something you don't provide it, you can have explanation that it is unpopulated, which means that property is not part of the data set maintained by the data provider. However, the characteristics may exist in the real world. For example, elevation of the water body above the sea level has not been included in the data set containing lake spatial objects. Then the reason for a void value of this property will be unpopulated. calculated. This is one example. You can have unknown, which means that the correct value for the specific special object is not known and not computable by the data provider. However, again, correct value may exist, which means again you have here example when the elevation of the water body above the sea level of a certain lake has not been measured, but of course it exists in the nature, then the reserve for a void value of this property would be unknown and withheld, which means this characteristic may exist but is confidential and not divulged by the data provider. So these are the reasons of voidability. Okay. Code list. Okay. Coverages, okay, and then which we said in the chapter 5, which is very important, you have to read this application schema or schemas if there are several application schemas. So in this case, actually for the C region there is only one, and here is the UML representation for the C regions. So this is what is important, and this is also what is actually written. Everything of this is written again in the implementing rule. I will not go now through this. There are several requirements. You can follow it through the data specification coming from the implementing rule. Recommendations, if you are using these technical guidelines, there are some examples here. The C regions are really the simple geometry actually on the seas. What more to say here? Okay, we have then feature catalog here with the objects defined for the C region, spatial object types. Then again some common parts regarding reference systems, units of measure and grids. Team specific requirements. Then we have this data quality. So you have data quality elements used in the spatial data team C regions, and these are the common elements. Logical consistency, positional accuracy, usability, minimum data quality requirements if they are defined. In this case there are no minimum data quality requirements for the C regions. Recommendation, also there are no specific recommendations on the data quality in the C regions. Then metadata, again common metadata elements which we saw already this morning. Some XML examples. Okay. Then we have delivery in chapter 9, which is a common. Then we have this chapter 10 with data capture, which is really a team specific. And chapter 11 with some common parts again and some specifics if they are specific for the particular team. In this case we have these layers to be provided with the Inspire View services. At the end there is a bibliography of the documents used. Then we go to annexes. We said there is Annex A, normative abstract test suite, with different types of tests. Don't read it, I think it's not necessary, but as we said, if you want to say I am Inspire conformant, then you should go through these tests, and then you can fulfill this, you can fill this metadata element about conformity, stating that you are conformant. And there are different tests actually. There are tests coming from implementing rules, tests coming from technical guidelines, so you can either be conformant to only implementing rules or to both, which means to implementing rules and to data specification. Okay, I will skip these tests. Then conformity with the technical guidelines, as I said. So these are the requirements coming from technical guidelines. Then there are some use cases here, usually as Annex B. And if there are code lists used, you can find in Annex C these code lists. more or less. Let's see if there is some more. There is here one informative Annex D with illustrative portrayal section, so you can find some examples from some countries how they are using in the portrayal for the sea regions. I'm without the voice. Any questions, or we go for the coffee break? Okay. I hope so. I hope so. Because there are some projects, actually not only this EULF, but it is the ARENA project. Maybe you heard. ARENA. I think that will be some presentations in next days to try to see. This ARENA project is actually trying to establish reusable components for the Inspire, and they're already providing some softwares, mostly open source. And I think one of the component there is also they are thinking about testing and these things, because this is really I would say, yeah, for some people it's important, for some maybe not so much, but I would say it is important. It is important to be able really to test, to make those tests, because you have, if we are speaking about data specification, okay, you need really to test if you provide all the objects that are in the implementing rules. But the problem with the data specification that a lot of those tests are actually cannot be executed automatically. This is the problem. So I would say for network services the situation is much more easier, because if you need to measure, I don't know, some seconds and how many requests can be dealt and so on, it's much more easier. But for data specification it's really challenging to develop. Maybe you can test schemas and such things, but not really. Okay. Yeah, and I think it's adopted already officially as an ISO standard. Yeah, I think so. Last year. Probably it's. Yeah, could be, but I think it's already it's published. I am actually sure that it's published really as an international standard. It's not anymore in the final disk, but probably when it was used in this technical guidance, maybe it was still in this final draft phase. Probably. Hope so, yeah. Hope so, but it's again related to ISO, no standard. Okay, thank you very much. Coffee break, and we will continue at 4 o'clock with really some practical exercises. We will use this Inspire Geo portal to try to discover some data. So for all of you who has notebooks, please try to bring them to the next session, so we can do it parallelly. You can try to search, to play a little bit with the metadata, let's say. Thank you, and let's go for the coffee break.